It's not all about taking bites out of sandwiches and making Eiffel Towers, but sometimes we can actually see real necessity for finding areas of exotic shaped regions. Let's check out an actual example. So a small theater has a floor plan with the dimensions shown in the figure. To efficiently air condition a room, 20 BTUs are required for every square foot. Our mission is to determine the minimum BTUs required for an air conditioner to cool the theater effectively. And we can round our answer to the nearest 100 BTUs. All right, so here's the theater. Interesting looking floor plan. And so what we first have to do is we have to find the area, because we're told that for every square foot we need 20 BTUs. So first let's find how many square feet, then multiply our answer by 20 to figure out the BTUs. Well, let's see. Very complicated shape here. I see a semicircular piece right here. Maybe that's like actually, like, you know, behind the, or maybe that's like the, so I don't know which is the front. I guess this is the front. This is like the stage. Maybe it's like the orchestra pit. This is, people sit here, and this is the very back of the theater. Who knows? Anyway, we've got a semicircle here. Then we've got sort of a rectangular sort of region here. And then here, we've got a trapezoidal region. Okay, so lots of stuff here. If we cut this up into pieces, we can find the area of each piece. So that's what I want us to do. So I want us to cut this up into this piece, and this piece. Let's find the area of each. Okay. Well, the area of the middle piece is pretty easy. It's just a rectangle that has base 20 and height 18, and so therefore it's 20 times 18, which is 360. So this is just 360. Feet squared. All right. What about the semicircle? Well, this we know is 18, so this whole diameter is 18. Half of it is 9. So the area of the entire circle is pi r squared, which is pi times 9 squared, or 81 pi. But I want the semicircle, so don't forget you got to take half of that. And so if we take half of it, we see 81 pi divided by 2, because it's a semicircle. Okay? And now finally we've got to find the area of this potentially more exotic shaped, or the most exotic shaped region of the three, which is the trapezoid. I know one base is 18, I know the other base is 12, and I've got to now find the area. Remember what you do, you take the average of the bases, so you take base 1 plus base 2 and divide by 2 and multiply by the height. Now where's the height here? The height here is actually given by that right there. I don't know that though, that's not given. So maybe we can't answer this question. Or maybe we have to think a little bit more. All right, so let's think a little bit more and realize that if in fact this entire thing is 18 and this is 12, then the stuff left over is actually going to be 6. And since this is 5 and this is 5, I know that the little stuff left over here and the little stuff left over here are going to have the same length. So I have to divide 6 evenly into 2 pieces, so that means that this little piece right here is 3. I've got a right triangle, a 3 blank 5 right triangle, 3 blank 5. Use Pythagorean theorem, or remember a 3, 4, 5. Awesome. Okay, now armed with that, what I see here is that my height is 4. This is 18 plus 12. So 18 plus 12 is actually going to be 30. And if we divide that by 2, we get 15. If we take 15 and multiply it by 4 to get the area, we see 60. So 60 feet squared. Oh, I should have written feet squared with the green. Great. Area, area, area. You add them all up, you get the total area. So total area equals, well, you've got to add these numbers up. So 81 pi over 2 plus 360 plus 60. All right, and you're saying, wow, that's the answer. We're done. Let's have a big party in the theater. No, this was a question about BTUs. So I've got to actually take this answer, and I've got to multiply it by 20. 20 BTUs per square foot of area. So BTUs equals 20 times this. So I got to take 20 times 81 pi over 2 plus, and this sum is 420. And if we round this, using a calculator and using 3.14 for pi, we see 10,945. And what did they ask us to round? Round to the nearest 100. So if I round to the nearest 100, I would say that this is very roughly 10,100 BTUs. Sorry, what am I saying? 900. Sorry. And so you get a really good sense of how many BTUs are required by finding the area of this exotic shaped thing, multiplying by 20, realizing the area is actually exotic, but it's actually the sum of half of a circle, a rectangle, and a nice isosceles trapezoid. Very cool.